Alright, so I just wrote this little script that uses a very simple definition of the fundamental circle constant, pi on 4, using continued fractions. It converges agonizingly slowly, but it's very simple to write. Yeah, so it's just in your convergence series, you end up with a list of numbers, right? So here what I've done is I've taken the inverse of a definition of 4 on pi, which means that basically the integer part becomes 0, it disappears, and everything just gets shifted over 1. So we lose this part. And instead of it becoming an underestimate all the time, and now it's an overestimate all the time. So here, this is the what you would normally consider to be this list right here. But because the 2 repeats forever, I just put 2r, right? So the 2 just goes, you know. You get a 1 out front and then 2's forever. And instead of 1, it's not a simple convergent or a simple continued fraction. It is a non-simple. The denominator is always this, 2i minus 1 squared, or whatever the next odd number squared. Right? But this works nicely because it gives us that first one, because if our index is 0, then we get 2 times 0 is 0, minus 1 is negative 1, squared is 1, which is exactly what we want right there. We want a 1. And then at 1, we get no, wait, let's see, 0. Yeah, at 1 we get 2 minus 1, which is 1, squared is 1 again, and then, yeah, it works. I know it works, I'm like, huh. So the algorithm is actually really, really simple. Most of this is actually just to clean it up and make it so that it was easier for me to see what was happening. Squaring in Python is a pain in the ass, so what I did is I just defined this component and then multiplied it by itself right here. Just made it, in the moment, it made it easier for me to see what was going on. And because we have to work from the tail forward towards the 0, I just used a different index here. You could have done here and just stepped it by negative 1. That would work as well. That's fine. Whatever. Always multiple ways. And then, yeah, because it's the inverse of the normal thing, there were issues here with me figuring this out. This took me a minute. But, so here, at 100,000, it closely approximates 4 decimal places. And so that it's 0.785389. But let's just do 100 so you can see what's happening there. Yeah, I know, because you're pathetic. You need me to save it. So 0.7878. Not fabulous. Let's drop that in. There you go. So this would be 389, blah, blah, blah. So 400 is quite close. So pretty much these 4 decimal places are very, very well approximated now. But it took 100,000 iterations. So that's terrible. Its convergence is exceedingly, agonizingly slow. But it does work. And it is very, very simple to write. I don't know how you would normally notate this, where you're, if there is even a conventional notation for this. So I just made this notation up. I figured this makes sense because this is the numerators, and this is the denominator, so it's just divided by whatever. Yeah. So don't take this notation very seriously, because I couldn't find anything, so I just made this up. Fucking, I need to write it down somehow, so fuck it. Yeah, but there we go.